Hey guys, it's Alec, and I am starting a new series called Code Drop, which is where I am going to be giving tutorials and kind of info segments on programming and pretty much anything tech related. So, a little bit about myself. I am a part-time software engineer at a little startup called Decipher Technology Studios. Been there for about 2 years now. I was there since the beginning. I'm a college freshman, so I go to the University of Maryland with my good friend Jack, who you will probably see on this channel. He's also working at Decipher with me, and it's a lot of fun. So enough about me. More about the series. Code Drop is basically I'm going to be demonstrating how to do kind of the latest and greatest web technologies with Go, or not just web technologies, but anything programming related with the language of Go, developed by Google. So yeah, I mean, this episode, I'm probably just going to be doing web server stuff, and I intend to make a series called that focuses on microservice architecture. That we're going to be building a cool microservice that is built on top of Go. But for now, we're just going to focus on building a really lightweight HTTP server, because I know a lot of you guys, that's a big thing now. You want to host your own website, serve up static files. That's actually really easy to do in Go. So for this episode, I'm going to focus on just building a really, really lightweight HTTP server that can basically serve up some HTML, CSS, and JavaScript, and can be deployed anywhere on, say, Amazon, an EC2 bucket, or an S3 bucket, or I'm sorry, EC2 instance or S3 bucket, or even on like a Google Cloud platform. And the best thing about this is it can all be Dockerized, or you can use Kubernetes, and it all wraps into a cluster environment. So that's really cool. So why don't we head right into the code? And if you're new to Go, you're going to need to set up your Go development environment. So the best way to do that is actually go to their website. The documentation for Go is just fantastic. You can follow I believe there's a documentation tab that you can click, and there's just wonderful documentation on how to set up Go. Go was created in mind that a lot of programming languages nowadays lack any sort of structure. I mean, people can code one way and someone else comes in and they have no idea how to read your code. Go was designed to kind of mitigate that problem. They wanted to create this sort of unification between developers. So if I write something, someone along the line comes, they can say, oh, I know what that code means. Let me make it a little better, or do something you can contribute, open source. The idea of Go is really fantastic. So enough about that. Once you've set up your Go development environment, you need to create your main.go file, which is your main process. This is where the program enters. Go is structured in packages. So you have your main package, then you can have all your other stuff, all your other code, but that's later on down the line. So right now, we just need our main function, and we declared our package. So we could save everything. All is well. I forgot to mention, you will need some sort of text editor or integrated development environment. And using a text editor, in my opinion, is better because you can customize it. You can add plugins that really enhance your experience. I'm using GitHub's Atom, that has a lot of Go development plugins that just really make writing Go a lot simpler and a lot easier, like IntelliSense. So enough about that. If we start to writing the HTTP server, the Go kit is a set of open source packages that Google has identified and said, okay, we really like these, you should use them. There's also the standard lib, which is all the code that comes pre-compiled in the Go binary that gets installed on your machine that you have access to. Not to mention, Go is all open source, so if you want, you can play around with the Go source code. The package we're going to be looking at is the net/http package, which gives us all the main functionality of the web server. So to declare a server, you can do something really simple, just a variable. When you're in a function, you can use the shorthand variable declaration, which is the :equals. And we need to do http.server, which is a struct, and of course, it is a struct is an object in Go. So in Go, the fields and properties are generally exposed if they're uppercase, and if they're lowercase, they're not. So we're going to focus on the uppercase, and for a server, you need to define a host and port. So for this, we're just going to do localhost, and we'll do 3000. So that's the server address. You need a comma delimiting the end of your line if you're inside of an object literal, which means you're inside this block of a struct. We need to define a handler, which for now we're actually going to leave nil because we don't have a router. We have no way of telling the Go web server what URL it's gonna send data back at. It's kind of just a dud. So we're gonna leave that as nil, which is the value for no value. We're gonna set a read timeout of 10 seconds. You'll notice the time.second. Time is a package, just like the HTTP package that comes pre-bundled in the Go standard library, which is really cool. So define a write timeout as well. It's generally good practice to define timeouts on your web servers. Otherwise, if something fails and it doesn't cut itself off, you're going to be sitting there for 5 minutes waiting for something to come back. So we've declared the server, and my text editor is telling me, okay, you declared this thing, but you're not doing anything with it. There's a cool built-in function to Go that it won't compile your binary if you have unused variables. So it really helps you clean up your code and really stick to the DRY principle of don't repeat yourself or don't have unused code that's unnecessary. You really want to write clean and concise code. So we're going to wrap a method called server listen and serve in a panic statement. Panic is basically if an error is thrown, shut the whole binary down, crash it, destroy it. That way your server is going to make a lot of noise. You can go fix all your problems, all is well. It really helps handling failures. This listen and serve method is actually going to start up our web server. So back to the handler property, that can actually be filled with things. So we're going to define a function called say hello. And in that function, we're going to define two parameters, a response writer and a request. What we've just done is defined a function that implements an HTTP handler. The HTTP handler is an interface, a really low-level Golang interface that allows communication between the browser, a HTTP server, and your router. We've defined that in our code, and because we've given the parameters HTTP response writer and HTTP request, we can plug it in to the handler field in our server. So let's say we're just going to do println, we'll pass in the response writer, and we're going to say hello world. So it's a good idea to document your code. You always want to document your code. We'll say hello is a hello world web server handler. Okay, so we're actually going to go replace this handler with our say hello function. That's not right. Oh, I'm sorry. We implemented an HTTP handler function, which implements the HTTP handler. It's kind of like a two-step process. So an HTTP handler expects, which is like a router, for example, expects HTTP handler functions. So we're actually going to declare a router using the mux package. The mux package, remember when I talked about the Go kit, is a open source package that Google recognizes and says, hey, this is a good thing. You guys should probably use this to make your life easier when you're developing a web technology. So we're going to do that, and we're going to add a route. Let's say handle. We're going to say it's just going to handle the default. We'll say it's going to at the base slash, we want to call the say hello function. Handle func. Okay, and then we're going to pass in our router as the server's HTTP handler. So now the server actually knows what to do when we access the root directory. So before we move on, it's generally a really good idea. Actually, it's common practice to log and have your server or service or whatever you're building make a lot of noise in the console or even a log file. So what that does is it allows operation managers, other users to see what's going on under the hood and really understand what you've done, what the service is doing, when it's doing it, who's accessing it. Stuff like that just makes development a lot easier. So Mux or Gorilla, this company, has implemented a really nice package called the handlers package. We're going to import that, and we're going to do handlers new logger, I believe. I'm sorry, I believe it's logging handler. Yes, it's logger handler, and then we pass in our router, which will satisfy the parameters. Not enough arguments. Okay. Well, we can check the documentation and see. Right, we need to tell it where to actually print. So a great thing about the Go documentation is it's really well written, and it's very easy to know what's going on. So instead of just passing our router directly, we've created this wrapper that accepts our router as a parameter. And what it does is it says, okay, we have this router, take everything that goes through it, log it to the console, and then pass it down to the HTTP server. So what we need to do is we need to tell this HTTP server to actually use the wrapper, which is essentially using the router, instead of just using the router. Because if we don't go through the middleware, then this is never going to happen. The logging is never going to happen. So if we were to pull up our console and we were to run main.go, we'll see it freeze. What it's actually doing is running our web server real time. So we can open up a browser and we can navigate. What port did we specify? Localhost 3000. We can navigate to localhost 3000, which is proxied to 127.0.0.1. And we will see we will see hello world. Sorry, I had something else cached from a previous project. So what's happening is our server just served up some plain text to the browser saying hello world. Remember, this function, all it does is just serve up plain text. And we specified a route as the base URL to call this function. So everything is working, and we can see that in our console, everything was logged that just happened. So you probably won't see this because that was from my previously cached project, but you'll see this HTTP/1.1 response code 200. That means it was a success. It had the host that called this was 127.0.0.1, which is localhost. It happened on this date. What kind of request was it? Well, it was a GET request. And where was it coming from besides the host? Where was it coming from within the browser? Well, it was at the root URL. So the logger is telling us that. It tells us the protocol, the response. Was it successful? It was. And then I believe this is how many bytes it sends back. So what we've done is we created a scalable, really lightweight HTTP server. So you can actually have this grow a lot. So if we were to do like handle func and say /user, we could create a function that says get user, and get user will return a JSON object. So a lot of APIs or application programming interfaces today communicate through JSON. It's like it's a very uniform, community used way of sending data back from a back end. So one of the really cool things about Go is it has built-in capabilities to work with JSON. So all of its internal objects, functions, everything, they all map to some sort of type of JSON. So you can start sending things back to the browser that you won't be able to do in Java without a ton of code. So Go has really focused on their web technologies. Hats off to Google for doing that, but this is a wonderful language. I really hope you guys enjoyed watching. I hope this was informative. Episode 2, we're probably going to focus more on the JSON aspect and actually sending back. And then episode 3, down the line, we'll talk to databases. There's a lot of stuff we can do, configuration, deployment, everything. So I really hope you guys enjoyed watching this. I hope you found it helpful. Let me know what I can work on and what you'd like to see more of in the comments below. Thank you guys, and I'll see you in the next one.